is the Chapter 9 review for pre-calculus. So we're going to start off with just some right triangle trigonometry. If we can figure that angle out. Up top, we don't have to, but if I take 90 minus 32, this angle would be 58. And if I take 90 minus 40, this angle would be 50. But what I'm finding here are the lengths of the sides that aren't given. So to find x, I'm going to use this smaller right triangle, and I'm going to use the 32-degree angle that was given, and this is adjacent to that, and I have the hypotenuse. So I'm going to use the cosine of 32 equals x over 10. And so x is the cosine, or 10, times the cosine of 32. And says to round my answers to the nearest tenth. So 10 cosine 32 is 8.48, approximately 8.4805. So we're going to call it 8.5 to round correctly. Y, I'm going to use this other triangle over here. I know, well, let's see, I need to know Z first, don't I? So I'll go back to this little triangle over here. Z is opposite 32, and again, I'll use the hypotenuse. So I'll use the sine of 32 equals Z over 10. So Z is 10 sine 32, and I said 10 sine 32. And I get 5.2, approximately 5.2992. So we'll call it 5.3. Okay, now I can find Y. Again, I'll use this 40-degree angle that was given, and I'll use Z, and then I'll use Y as the hypotenuse. So the sine of 40 equals Z, which is 5.2992 over Y. And so here, when I solve this one, it's going to be Y times the sine of 40 equals 5.2992, and then I would divide both sides by the sine of 40. So Y is 5.2992 divided by the sine of 40. And I've already got this number in my calculator, so I'm just going to hit divide and then sine 40, and it'll use that number with all the decimal places, which is what we're supposed to do. And I get Y is approximately 8.2441, so we'll call it 8.2. Okay. I don't think I'll have room to do the rest of these problems on the actual worksheet. So we look at number 4, and it says that a kite, here's my kite, is 250 feet above the ground. How many feet of string are used if the angle of elevation is 55? So this angle of elevation is 55, and we want to know how much string is used. So with respect to this angle, I have the opposite side, and I'm looking for the hypotenuse. So I think sine would work. Sine 55 equals 250 over x, and then again to solve that, I cross multiply, I get x sine 55 equals 250. So x is 250 divided by the sine of 55. And also supposed to round our answers to the nearest tenth. So 250 divided by the sine of 55 gives me 305.2. And then don't forget to label your answer. It's 305.2 feet. And then we have triangle PQR. Its area is 36. Doesn't say it's a right triangle. So triangle PQR. The area is 36. Little p is 8. Little q is 14. And we want to find the possible measures of angle R. Okay. So the area, the formula for area is 1/2 PQ sine R. Okay. So they gave me the area, they gave me P, and they gave me Q. So I should be able to solve this for R. And so let's see, 72, getting rid of that 1/2, and then 8 times 14 is 112. And then 72 divided by 112 is 0.6428571429. I'm going to take the inverse sine of that. So second sine, and then I'll hit second answer, insert that decimal, and I get 40.005 and 20088 da 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 da. So we are still in the directions where it says round answers to the nearest tenth. So that's actually going to round to 40.0. That's an acute triangle, and we could have a similar triangle, but the obtuse version would also. So the measure of angle R is 40.0, or the measure of angle R is 180 minus that, which would be 140.0. Okay. Both possibilities have to be there. If we had gotten, well, no, I'm not going to say that. Never mind. Number 6. Okay. Again, we have triangle ABC. So A, B, C. Little a is 3. Little b is 5. And the cosine of C is 0.3. Okay. So we're supposed to find the sine of C. And we've gone over 2 methods of doing that. One method is to use the identity sine squared plus cosine squared equals 1. And the other method is to pretend that we temporarily have a right triangle and we figure it out based on Pythagorean theorem and blah, blah, blah. Technically, if we can, we're supposed to use the identity, which is what we would use in more advanced classes. So Sine squared c plus 0.3 squared is 1. So we get 1 minus 0.09. We get that sine squared c is 0.91. We would take the square root of that and get that the sine of c is not a pretty number, 0.9539392014. Pretty sure on the test that comes out to be a much nicer number. So for number 6, find the sine of c. Okay, we just did. And now we want to find the area. So the area of this triangle is going to be 1/2 times 5 times 3 times the sine of c, which is that decimal up there, that big long decimal. Well, I still have that big long decimal in my calculator. So basically all I'm going to do is take that times 15 and then divide by 2, and I get 7.1545, and again we're supposed to round to the nearest tenth. So the area is 7.2, and I don't see any units. Okay. Next, we're supposed to find little c. Okay. So for that, I would use the law of cosines. I would say that c squared is a squared plus b squared minus 2ab times the cosine of c, which is 0.3. So, let's see, 9 and 25 is 34 minus 2 times 3 times 5 times, and I get 9. And 34 minus 9 is 25. So c squared is 25. So c is 5. I don't think I meant for that to be an isosceles triangle. I think I did my math right. So, and then it says find the sine of a, and to do that, I would probably use the law of sines, where I use the sine of a over a equals the sine of c, which is that big long decimal we found, over this, right, over c, which is 5. And so let's see, 3 times 0.9539392014 divided by 5. And that gives me the sine of a is 0.572363528. Again, we're not finding the angle, they just want us to find the sine of a. And so there it is, round it to the nearest tenth, and so your answer would be 0.6. Okay. And as I said, I think that I just go in and change numbers. I'm sure the numbers on the test work out to be a little bit nicer than that. So here we are on number 10 in triangle XYZ. X, Y, Z. Angle X is 20. Angle Y is 40. and little z is 11. Find little x, which is over here. And I would use the law signs. This is 40, this is 20, that's 60. From 180 means this angle is 120. So I would take the sine of 120 over 11 equals the sine of 20 over little x. I think you could also use law cosines here, but let's see. No, couldn't, because you'd have to know little y. Anyway, so x sine 120 equals 11 sine 20. X is 11 sine 20 over sine 120. And those of you that are thinking, oh, sine 120, we know that angle, we got to give the exact answer. No, we really don't. I mean, we do know that angle, and we can find the exact sine of 120, but sine of 20 up here, we do not know. And so we're not going to mix an exact answer with an extremely weird, irrational number, okay? We would want the whole answer to be the decimal. So we take 11 times the sine of 20, and then press equals, divided by the sine of 120, and press equals. And I get that x is 4.34424, and we are supposed to round our answers to the nearest tenth. So the answer there would be 4.3. Number 11, find the perimeter of a regular pentagon inscribed in a circle with radius 40. So regular pentagons go a little bit like this. So if they're telling me the radius is 40, that means that is 40 and that is 40 in my pentagon. And this angle would be 180 divided by 5, because there are 5 sides. That's a 36-degree angle. And we're supposed to find the perimeter. So I would call this x, and then I would use the law of cosines to find x. So x squared is 40 squared plus 40 squared minus minus 2 times 40 times 40 times the cosine of 36. And of course, you know, there's more than one way to get to Bloomington. I could have drawn this altitude in and separated this angle and made it 18 and 18, and then found, you know, temporarily call this A or whatever, and found that using just regular right triangle trigonometry. I've already kind of embarked on this adventure here, so I'm going to stick with it. 1600 and 1600 is 3200 minus 2 times 40 times 40, then multiply that by the cosine of 36, and we get a large number, 2588.85438.2, da 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 da. But I'm going to take 3200 minus that. So I can just use the second answer key there, and I get that x squared is 611.145618. And then I take the square root of that answer, and I get that x is approximately 24.72135.955. And then I multiply that times 5. And so the perimeter, and I believe we're supposed to round to the nearest tenth still in the directions. The perimeter is 123.6. And they did not give me units. Yes, they did. Centimeters. There we go. Okay. Number 12. So one angle of an isosceles triangle has a measure of 110 degrees. So if it's only one angle, it's got to be this vertex angle. Oops. So that's 110. The area of the triangle is 9. What is the perimeter? Well, these are congruent, right? Then I would also need to know this. And for the x's, I can use, k equals 1/2 x times x times sine 110. So 9 equals 1/2 x squared sine 110. And then that gives me 18 divided by sine 110 is x squared. So x, I'm going to do two things here at once. See how that works out for me. I'm going to take 18. First, I'm going to take the square root of 18 divided by the sine of 110. And I'm going to get 4.37. 6665. Okay, so there's x. And then to find y, I would use the law of cosines. Again, you could also draw in that altitude and use the right triangle trigonometry and find, half of this first. That's fine too. Y squared equals x squared plus x squared minus 2 times x times cosine of 110. And so x squared plus x squared, so what I did was I squared what I had as my answer, and I'm going to multiply that times 2. And then I'm going to subtract I'm going to take 2 times x, which is 4.37666536 times 4.37 times the cosine of 110. And what that means is for this, I got 38.310399981. And for this, I got negative 13.1029 da 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 da. Okay. And so subtracting that negative is, I'm going to actually be adding those together. And so I get 38.310399981 minus that answer, is 51.4133. I'm going to guess the answer is 7.2. Now I want to take the square root of that, not that. Get 7.17, which is 7.2. My guess was somewhat accurate. And so then I just add. So the perimeter is that 7.17 plus 2 times 4.376665. Perimeter is 15.9, if I round it correctly, centimeters. And then lastly, a triangle has sides 4, 7, 8, and 9. 4, 7, 9, no 8. No 8 in there. What is the smallest angle? So the smallest angle is opposite the smallest side. So that's going to be this angle over here. We'll call it A. And this is definitely a law of cosines problem. So I'm going to take 4 squared equals 9 squared plus 7 squared minus 2 times 9 times 7 cosine A. 16 equals 130 minus 126 cosine A. So I'll take 16 minus 130. I get negative 114 equals negative 126 cosine A. And so negative 114 divided by negative 126 gives me a decimal. Less than 1. So the cosine of A equals that decimal. Then I take the inverse cosine of that. And I get that A is approximately 25.2087653, and it doesn't tell me what to round to, but everything else on the test was round to the tenths place, so we're going to call it 25.2 degrees. Okay, and that's it.